Hello students, today I am going to discuss with you testing of hypothesis. In this segment I am going to discuss with you people t-test which is applicable for the small sample. Those samples whose sample size is less than 30. So t-test static is defined as x bar minus mu s by root n, where s is square root of x minus x bar whole square over n minus 1. Now, what is x bar? X bar is mean of sample. Mu is population mean. S is standard deviation of population. Okay. So, this is the way how we can define t-static. Now, what we have to follow the procedure to apply t-test. First, we will assume a null hypothesis. Okay. Then, we'll assume a alternative hypothesis. Alternative hypothesis can be of three types. Two-tailed alternative hypothesis, right-tailed alternative hypothesis, and left-tailed alternative hypothesis. Third step is level of significance. Level of significance, the probability of the value of the variable falling in the critical region is known as the level of significance. These terms we have already discussed in our previous lectures. We first calculate degree of freedom, then use t-table that on the degree of freedom at 5%, which is taken as 0.05, and 1%, which is taken at 0.01. What is the value of t static? Now, fourth step is compute t static on the basis of the given data and using the formula above discussed. That is again mod of t equals to x bar minus mu upon s by root n. Represent it as t observed. OB stands for observed. Now find t tabulated, TAB tabulated on the basis of degree of freedom and level of significance. Now I am going to define the degree of freedom. The total number of observation less than the number of independent constraints imposed on the observation is called degree of freedom. Thus, V, which is represented as a degree of freedom, equals to n minus k, where k is the number of independent constraints in a set of n observation. Generally, it is n minus 1. In case of distribution, that is probability distribution. So, in binomial distribution, because we have no any parameter, it is n minus 1. In Poisson distribution, it is n minus 2 because lambda is one of the parameters, so it will become n minus 1 minus 1, that is n minus 2. Normal distribution, it is n minus 3 where mu and sigma are the two parameters. Calculation of t tabulated. See the table attached with the notes. I am attaching my table with this notes. Now, how can we read the table? In the table, the left hand side denotes the degree of freedom and the upper row is given the level of significance. Suppose our degree of freedom is 1 and level of significance is 5%, that is 0.05. So the data we can study as depicted in the table. And conclusion, if our t tabulated which is depending on degree of freedom and level of significance is greater than equals to t observed is which we have calculated, that time null hypothesis accepted. If it is less than observed value, null hypothesis rejected. Fiducial limits. If our hypothesis is rejected, then we can calculate the fiducial limits and it is given by x bar plus minus s by root n t alpha. Alpha is level of significance and t alpha which the value of t which we have calculated from the table. Now, t-test is used for test of significance of mean, single, follow the above procedure which I have discussed above. And if we are testing the two sample of a same population, then we will follow all the above mentioned steps except the step number 4th, where t observed can be given by x bar minus y bar upon s root of 1 plus n1 plus 1 upon n2. Here, x bar and y bar are the mean of the samples and n1 number of samples of x and n2 number of samples for y. Here, degree of freedom will be n1 plus n2 minus 2. Remark, if the two samples deviations are given, that is S1 and S2, then we can find the S square by the mentioned formula. Now we will discuss some solved problems. Example, a random sample of size 16 has 53 as a mean. The sum of squares of the deviation from mean is 135. Can this sample be regarded as taken from the population having 56 as a mean? Obtain 95% and 99% confidence limit of the mean of the population. So first of all, what we have understood from the above problem? The above problem states that we have a sample of size 16 which has a mean 53. And we have to prove that it is drawn from the population whose have mean 56. Okay, and here confidence limits are 95% and 99%. That is, our level of significance is 5% and 1%. Now we'll solve the question. Null hypothesis H0. Here there is no significant difference between the sample mean and the hypothetical population mean, that is mu equals to 56. Alternative, we are taking here two-tailed, so we are taking mu is not equals to 56. Level of significance, it is already given in the problem, 1% and 5%. Now, given that the sample mean x bar is 53, mu is 56, n is 60, and summation of x minus x bar is 135. So first we have calculate the standard deviation. So S is square root of summation of x minus x bar whole square upon n minus 1 equal to root of 135 upon 15, and that is 3. Now we'll calculate T observed. T observed is x bar minus mu upon S over root n, and that is 4. Degree of freedom. Degree of freedom, because sample size is 16, so 16 minus 1 is 15. Here no any distribution is given in the problem. Conclusion. We have now calculate the T tabulated by seeing the table for the degree of freedom 15 and the confidence interval of 5% level of significance, and it is 2.13. So what it depicts? Our T observed is 4, but T tabulated is 2.13. It depicts that our hypothesis is rejected because T tabulated is less than T observed, as I have described above. Now, for the 1% of level significance, it is 2.95. Again our hypothesis is rejected for 1% level of significance. Now, as I told you earlier, that fiducial limit can be calculated only on those points which have when the hypothesis is rejected. So we'll calculate the fiducial limits for 5% level of significance and 1% level of significance. So we have now draw the limits are 54.5975, 51.4025 for 5%, similarly 55.2125 and 50.785 for 1%. Next example, here the items, 9 items of a sample size are following. Here the observations are given. So we have to calculate remaining things from this observation. So here sample size is 9. So first of all we'll calculate the mean, which will help us to calculate mod of x minus x bar whole square. For this we can calculate standard deviation. We will assume null hypothesis H0, mu equals to 47.5. Alternative, mu is not equals to 47.5. Here, because level of significance is not given, we are taking it, assuming it 95%. That is 0.05. Now we'll calculate T observed by our described formula and T tabulated from table, and conclusion, here H0 is accepted. Now we will take one example for 2 sample means. So here 2 samples are given, sample size 8 and 7, sample means are given, sample standard deviations are given. So null hypothesis, they are drawn from the same population. Alternative, mu1 is greater than mu2, that means first mu1 is greater than first mean is greater than second mean. And then we'll calculate, because it a right tilted, because mu1 is greater than mu2. Now we'll calculate standard deviation, and similarly we will calculate T static, and now here degree of freedom is n1 plus n2 minus 2, that is 13, and 1% of level of significance we are taken over here, and that is 1.77. Conclusion, since calculated T observed is greater than TL, H0 is rejected. Thank you so much. Later on, we will discuss about F test and chi-square test.